In section 8.5, we are going to learn the determinants and the Cramer's rule. And for here, I'm going to separate that into two parts. Part 1, we are going to learn about the determinant. So determinant is a real number associated with every square matrix. I have not yet found a really formal definition of that, so I'm going to share with you the properties of the determinant. It is a real number. Not a matrix, okay? And it can be negative number. It is not associated with absolute value that or except that they both use vertical line. What I meant in here is in the notation of the determinant of a matrix looks like an absolute value, but it's not. This is a determinant notation. Or sometimes we write it as DET. That's the determinant of the matrix, but it's not an absolute value. And the determinant only exists for the square matrix. So the square matrix like 2 by 2, 2 by 2, 3 by 3, and so on, right? The row and the numbers, number of row and number of columns are the same. The determinant, I did not say about the 1 by 1. Of a 1 by 1 matrix is that single value in the determinant. If we are looking for the inverse of matrix, then the inverse of a matrix will exist only if the determinant is not 0. So those are the properties of the determinant. You might wondering, well, what exactly the determinant is and how to find the determinant. Let's take a look of the 2 by 2 matrix first. Let's say you have a matrix A. It is A1, B1, A2, B2. So that's row 1, row 2 element. Okay. And determinant A, we are going to find the determinant of this matrix. That's equals to you do the diagonals. Okay, so this one multiplied by this one, main diagonal, and minus. So it's equal to A1 B2 minus B1 A2. Let's take a look at an example for this, how to find this determinant. Let's find the determinant of this matrix A is defined as -9, -18, 2, 4. So the determinant is equals to main diagonals product, -9 times 4 minus the minor diagonal, -18 times 2. So that is equals to -36 plus 36 equals 0. And so you have this is determinant has a value is 0. How about another one? Let's say B is equals to 5, 6, 7, 3. So the determinant of this matrix B is equals to diagonal 5 times 3 minus 6 times 7. That is equal to 15 minus 42, which is equals to -27, right? So you can see as I mentioned, the determinant is nothing associated with the absolute value. It can be negative, it could be 0, or it could be positive as well. Now let's go to take a look at how about the 3 by 3 matrix. And sometimes we call that is third order determinant of 3 by 3 matrix. Sometimes we can call this is third order determinant. Well, alright, again, if we have matrix A defined as A1, B1, C1, A2, B2, C2, A3, B3, C3, be honest, the formula is a little bit hard to memorize that, but I'm going to show you like a shorter way to understand how we calculate that. Oops, it's the determinant. So this one is, so you are going to do the routine minus, plus, minus, plus, minus, plus, and this one is equal to, so first we are going to select A1, right? So the A1, we have cross the corresponding row, cross the corresponding column. So A1, we multiply the another matrix determinant, the determinant which is the one you cross after you cross B2, C2, B3, C3. Okay, and minus, so we go on to the column way. Okay, so the next one is A2. So do the same thing. I'm going to cross out the corresponding row, cross out the corresponding column, the A2 times, so what we have left in here, B1, C1, B3, C3. Okay, we do one more cross in here. So that one is I'm crossing this one and crossing this one, plus A3, B1, C1, B2, C2. Now that's going down to 2 by 2 determinant. Right? So this will be A1. Remember the 2 by 2 determinant, how to find this? So it will be B2 C3 minus C2 B3 minus A2 times B1 C3 minus C1 B3 plus A3 times B1 C2 minus C1 B2. If you gathered all those information, make some arrangement, then we will get into A1 B2 C3 plus B1 C2 A3 plus C1 A2 B3 minus A3 B2 C1 minus B3 C2 A1 minus C3 A2 B1. Because this is very complicated to memorize, but it will be much easier if we understand how it come from. Right. So we call this method is expansion by minus. So this, because those are called minus of this element. Let's take a look of an example how we find the determinant of the 3 by 3 matrix. Okay, let's take a look at the first matrix. Matrix is 2, 3, 1, negative 1, negative 6, 7, 4, 5, negative 1. Right. So that is equals to, use this one, and 5 is corresponding, minus. So that's 2 times determinant of negative 6, 7, 5, negative 1. Okay, so the next one is negative 1. And take away of the corresponding row and column. So minus negative 1 times the determinant of 3, 1, 5, negative 1. And the last row, last element is this one. Take away the corresponding row and column. That will be plus 4 times 3, 1, negative 6, 7. Right. So this is 2 times negative 6 times negative 1 minus 7 times 5. Second, I can just apply the negative got positive, and we get 3 times negative 1 minus 1 times 5 plus 4 times 3 times 7 minus 1 times negative 6. Let's simplify this. So that will be 2 times 6, positive 6 minus 35. That's negative 29. Okay. Plus 1 times any number is a number itself. So that's negative 3 minus 5, negative 8. Plus 4 times 21 plus 21 plus 6, that's 27. Right. And that will be negative 58 minus 8 plus 108. Right? So that's negative 66 plus 108, that would be positive 42 is the determinant. Let's see another example for that. Say matrix B is defined as 4, 1, 0, negative 9, 3, 4, negative 3, 8, 1. Alright, so the determinant of this, again, first element, find its corresponding minor. So it's 4 times 3, 4, 8, 1 minus the second one, take away the corresponding row, corresponding column, negative 9 times 1, 0, 8, 1. And the third one is this, you take away of the corresponding row and column, plus negative 3 times 1, 0, 3, 4. Let's simplify. 4 times the determinant of these two second order determinant, 3 times 1 minus 8 times 4 plus 9 times 1 is 1 minus 0 minus 3 times 1 times 4, 4 minus 0. So that is 4 times, this is negative 29 plus 9 minus 12. So we get negative 36, right? 4 times 9, 36, 116 plus 9 minus 12. Negative 95 in here. Oh, no, I cannot do my math. Sorry. And that's negative 128, so negative 119 right here. That's your determinant. All right. So, how about the n by n or more than 3 by 3 determinant? How to find that? Then you are just going to apply what we use for the third order. You just knock down them one by one, and you can find the others. All right. Then I see you in the next part.